Hi everyone, welcome to another video. So this is still a tad bit revision from what we did last year, but we want to just look at one question before we move on to some of the harder stuff we do in year 10, just getting us in the feel for problem solving and making sense of worded questions, because this is often where people struggle. I thought I'd include an applications of trigonometry to worded problems video, just so we can see how we would model a worded question like this before we move on to all of the new stuff. So in this series, I'm skipping bearings and 3D trig because we looked at them last year and they're not too different in the year 10 course. So just another video getting us thinking about right angle triangles, solving problems, and this will give us a nice base before we move on to some of the trickier things in this series. So like with all worded questions, we want to underline all of the important bits of information because we want to make this little few sentences here into a picture that we can solve. We want to make this look like some kind of right angle triangle that we can use trigonometry to solve. So let's start by highlighting the key points. So we have two vertical buildings are positioned 57 meters apart. And these are 158 meters and 237 meters tall, respectively. Find the angle of elevation from the top of the shorter building to the top of the taller building. Correct to the nearest minute. Okay, so we have two buildings 57 meters apart, and those heights are 158 meters and 237 meters. Okay, so let's actually go ahead and just draw two buildings here. So I have my first one here. This has a height of 158 meters. And I have another building here. And that is a height of 237 meters. Okay, cool. And we also have that they're positioned 57 meters apart. So the distance between these two buildings is 57 meters. Okay, sweet. So we want to find the angle of elevation from the top of the shorter building. So from this point here, top of the shorter building, to the top of the taller building. Now, like I said at the start, we're dealing with trigonometry here, which is the study of right angle triangles. So far, that's all we know about it. So we want to find some way to draw a right angle triangle here. Okay, so we have an angle of elevation. So that means that I'm looking at from here to here, this point to this point, and an angle of elevation, that bit that goes up, so this line here, that's measured from the horizontal. So from this particular straight kind of from this bottom point, this kind of eye line view pretty much. So if we were standing on this building at this point and looking straight ahead, that's going to be the horizontal here. So if you look at this little imaginary line I've constructed here, and this kind of eye line, imaginary line I've constructed, as well as the bit on the taller building between these 2 points, I now have a right angled triangle. So I'm just going to label that in now. So I have a right angled triangle because I have a right angle, because horizontal and vertical, those are always perpendicular. So horizontal and vertical, perfectly horizontal, perfectly vertical, they always meet at 90 degrees. So I have some length here of 57 meters, and the length here is going to be the difference between my taller building length, so this thing here, and my shorter building length. So let's just call this point here x. To find x, I'm going to find the difference between these two heights, which is going to be 237 and 158. I'm subtracting one from the other, and here I get 79 meters. Okay, so I now have my height. So instead of the height of my right angle triangle I've constructed here, so that's 79 meters. Beautiful. Okay, and now I can just take this right angle triangle and let me actually just draw it down the bottom. So now this looks exactly like the questions we've been doing in the past. I have 78 meters and I have 79 meters and 57. Now I know this isn't to scale. Let's actually write that here, not to scale. Okay, and I'm finding the angle of elevation. So what angle is that? Well, the angle here between the horizontal to this point and the inclined bit that stretches from here to here. Okay, so I'm looking for this angle here, theta. Okay, now it just becomes a question we've done in the past. I have my angle theta, I have my hypotenuse here, I have my opposite to it here, and I have my adjacent here. So using SOHCAHTOA, I can select the relevant sides, and that's going to tell me which trig ratio to use. So I have opposite adjacent here, so I'm going to use tan. So I have tan of my angle theta equals to opposite over adjacent. So 79 over 57. Okay, so now that I have it written out like this, I can isolate my theta by taking the inverse operation of this tan. So my theta comes here, and remember we looked at this inverse operation in the past. I can get the tan to the other side by taking the inverse. Tan of 79 and 57. Okay, so once I put that in, I get an angle of roughly 54.188 ... And if I wanted to round this to the nearest minute, because that's what the question asks me, we want an answer, angle value, correct to the nearest minute. I can put this into my calculator. Now, just a reminder, we can generate this once we have our answer. We can put this in the calculator with this little button here if you have a scientific calculator, and that gives you your answer in degrees and minutes. So this is going to give me 54 degrees and 11 minutes. This is how we can apply trigonometry and construct these little imaginary right angle triangles in order to solve a variety of problems. So we're going to do the same thing every single time. We want to underline the key ideas, we want to draw a picture and try to draw a right angle triangle somewhere. Because remember, we're doing trigonometry here. So we need to get a right angle triangle in order to use trigonometry in the first place. And this shows you a nice, hopefully concise way of working through these types of questions and making my initial drawing into a really easy right angle triangle. Makes it like a question we've been doing a lot in the past. But thank you so much for joining me, and I will see you next time.